All right, good morning, everyone. My name is Dave Gallagher. I'm with the Ohio Department of Transportation's UAS Center. We're in Drive, Ohio, which is our autonomous vehicle hub. So they do the kind of the ground infrastructure. We do the air infrastructure. So if you kind of imagine what the Ohio Department of Transportation's tasks are now, we build and maintain our ground transportation infrastructure, so roads and bridges and putting in new pavement. So likely in the future, DOTs around the country will be responsible for putting uh, infrastructure in the air. So it's almost like highways in the sky. So if you kind of think of that going to this, will kind of give you an idea as we go along here. So I'm the flight operations manager. I hold an FAA certificate for private pilot and remote pilot certificate. Another thing about that before I forget, Ohio Department of Transportation has put a free online course to obtain your FAA remote pilot certificate. So if anyone's interested in that, my contact information will be at the last slide. So you can email me. I can send you a link if anyone's interested in pursuing that certificate. So we'll just jump right in here. So we were formed in 2013. Our primary objective is to support and conduct operations for the Ohio Department of Transportation. It's a newer technology, so we develop and implement policies and procedures. We also have a lot of our contractors. Our contractors are the ones that build the roads and bridges primarily. They're using this technology to do measurements and stockpile quantities and things of that nature as they're helping us build and maintain our ground infrastructure. So they launch and recover their vehicles from our right of way. So we have an approval process we have them go through in order to make sure they have their insurance and everyone has their certificates and they're doing operating safely because they're close to traffic and we don't want to get in a situation where they're dropping vehicles in the middle of traffic. That'd be problematic for us. So we're a shared service, so we work with a lot of other agencies across the state and local counties, just to name off a few of them here. The Ohio Department of Public Safety, Ohio EPA, Ohio Department of Rehabilitation and Corrections, Ohio Department of Natural Resources, Ohio Department of Agriculture, just to name a few of them here. We will talk more about that with some use cases as we go on here. So what is UAS? It stands for uncrewed. The vernacular has kind of changed. It was unmanned, but they've kind of switched it nationally to uncrewed. Uncrewed aircraft systems. The reason why they call it systems is because it really is a system of things. You have the operator, you have visual observers, and you have the aircraft, which everyone kind of draws to that. That's the sexy thing. But the sensors are one of the most important things because that's your requirements. Do you want a thermal camera? Do you want electrical optical? Do you want LiDAR? Whatever your use case is, you match that. The data is the really important thing. Think of these aircraft as knowledge delivery machines. I've talked to farmers, and some of them will say, I'm using a drone and I've been farming for 30 years. If I just get a picture in the air, I can tell you what's going on with my field. I don't know if that's true or not, but that's what a farmer told me. There's also more scientific data you can use for looking at thermal technology, looking at wet spots, looking at dry spots, maybe some blight on some crops. So think of it as like that, a whole system that is being operated. So one of the primary reasons why we use this at the Ohio Department of Transportation is it increases efficiency, it increases safety. So that saves us state time and money. You can see these folks up here. This is in Toledo, the Veteran City Skyway Bridge. We typically have folks that will climb this, rappel it, look at all the joints, look at all the connections. A few years back, we had a bolt that sheared off the top of here, and those are glass panels. So we were able to not have someone climb up there and take a look at it. We took a drone out of a box, was up there in a matter of minutes, so we were able to determine that wasn't a safety factor for the breakage of the glass panel. So it is a really efficient way to collect data. So here's a quick glimpse of our flights that we've been doing lately. You can see we've had a pretty big uptick. We're hiring more folks inside the Ohio Department of Transportation, your surveyors, your bridge inspectors, traffic folks, engineers, construction personnel. So we jumped from 2023 to 2024 by 40% on our operations. So we've had a pretty big uptick because a lot of folks are getting used to this technology. They're putting it into their daily operations, and we're constantly training new folks. Here's just some more data. I'll just kind of skip over this. So here's our aircraft fleet. We have 96 drones. They're not all up here, but we use it for aerial photography and GIS, which is mapping, basically. Exterior and interior inspections. So we look at our facilities, our equipment. Our bridges, we fly them inside bridges sometimes. You'd be surprised how big some of these spaces are inside bridges that we inspect. Traffic monitoring is a big one, so we can tie all of our aircraft into the OGO cameras. You'll see those on the local news, and you drive past on the highway all the time. We also use them for blind spots. We filled in some blind spots during the eclipse because we are expecting more traffic last year. Um, Communication, promotional videos, our videographers inside ODOT headquarters. We have 3 certified pilots that have gone through our training. We do a lot of work zones, so this is orange barrel season. So you see those orange barrels, one of us are probably out there getting stockpile quantities, looking at their progress. We'll talk more about that. Safety funding projects, we're always trying to get more money to make our roads safer, applying for federal grants. Look at a lot of road signs and light pole inspections. We got a lot of light poles. People kind of underestimate how many light poles we have. So sometimes they get stuck. We'll send a drone up there, take a look what's going on, and try to repair it as we can. So we have some fixed wing aircraft. We've got SkyDOs, which are maiden bridge inspection. It works here. Orange one's more of a mapping aircraft. These little guys are great. They tie into our VRS cores network so we can get high level accuracies when we're doing design level projects. We've got some heavy lift aircraft that's about 55 pounds. We use a magnetometer. I'll show you some examples. Skydio X-10 is our newest one. We're replacing all the Chinese aircraft with that fleet. And we work with Ohio Department of Natural Resources and Ohio Department of Health for radiation detection with this one. So just give you an example of some of the stuff we've been using. So I mentioned before, we've trained a lot of folks inside the Ohio Department of Transportation. We call this the drone deployment program. One of the interesting things about the FAA Part 107 certificate is you just take a 60-question exam and the FAA says you're good to go for flying. So there's no practical training. When I got my private pilot's license, it took a lot of training hours inside of an aircraft. As I mentioned before, there's none of that. So we train all of our folks inside. We're up to about almost 50 folks from around the state, and that number is growing. So they usually come out to our facility for about 2 days of training. It takes about 3 hours to get someone proficient on the aircraft. Then we'll kind of turn them loose to their home district where they're required to get 10 hours of flying. Once they're done with 10 hours of flying, we'll go out and meet them on a site, a project site, and make sure they're doing everything safety. They haven't developed any bad habits. We got this little QR code that folks sign, and an email comes to us, and we'll put them through our training process. So as I mentioned before, one of our biggest use cases is the work zone. So as I mentioned, this is orange barrel season. So we look at the progress of the construction. We can look back at our setups. All of our contractors have to submit a plan. We want to make sure they're following the plan and not putting wall barriers or any orange barrels in an unsafe environment, or they're parking their cars where it's not going to interfere with our motorists. Contractor disputes, this happens all the time. So we've got video evidence of all the stuff being placed out there. Maintenance of traffic. So when you're driving down a highway during construction, you'll see the barrier walls. We'll change those as we're developing our projects. So we'll move those. We want to make sure those are going in place properly. A lot of local governments ask us for updates. So we'll send to local governments for public information office type of events, and they'll post it on their social media. So it's a good way to kind of show progress when we're building roads and bridges. I mentioned before safety funding. So the way we're designing roads and bridges have really changed over the last 10 years. Something like this shouldn't exist anymore. We've got crash data that says this is a highly dangerous intersection. So we'll apply for federal funding to put in roundabouts at areas like this. So they work roundabouts. There's no head-on collisions with the roundabouts. So that's why you'll see a lot of those going in there, because fatalities happen at these, and we shouldn't be building any more of these in the future here. So we do a lot of tornado response, a lot of natural disaster response. This was a tornado in Logan County by Indian Lake last year. We responded to that. We worked with Ohio EMA, the governor's office, Ohio National Guard, and we gave all the data to those folks, and they were able to put a damage assessment report together to give it to the governor so he could declare a state of emergency in Ohio. So we do a lot of stuff like that as well. Oh, go backward. So this is what we call a mega project. This is up in the Toledo area. So there's a lot going on here. This is over the Miami River, and we have a lot of ice that builds up here, so that could be problematic. They're putting in a new bridge here, so this is hard for a construction project manager to see everything that's going on. We've got cranes. This actually moves. Nope, doesn't have a video on it. But there's a lot of, you can see orange barrels over here and all the cranes and everything and the piers. So we can get a lot of information instead of having a construction project manager drive down that highway when he can't really see it. So that's very helpful for our folks to determine how things are going, if everything's going according to plan. As I mentioned before, the way we build roads and bridges and on and off ramps has changed. So one of our biggest issues is traffic building up on freeways. This is, during rush hour, typically, everyone's coming out during the same time. Traffic builds up here, it goes on the highway. That inevitably causes fender benders, and it's a safety hazard for our motorists. So we'll put in more fancy on and off ramps and have the flow of traffic increase by just doing signal changing and separating the lanes. So you can see when we first started, it was kind of the old fashioned way we used to do it. And you can see the progression going here. Then you can see the 2-lane split here, and traffic can flow both of these ways too. So we're not, so we're taking control of both eastbound and westbound. That's I-70. So well, you don't think about this too often, but Ohio is almost surrounded by water. So we got the Great Lakes to the north. We have Ohio River to the south. So we have some 44,000 bridges in Ohio. Ohio Department of Transportation maintains about 12,000 of those. The rest are split up between the county engineers' offices. We've got 88 counties in Ohio, so we kind of split the load on that one, but we're always building and maintaining new bridges throughout the state. So this is a pavement project. So I'll let this play here. So this is hundreds, maybe even thousands of pictures stitched together. So we can get high measurements, we can get progress, we can see the new pavement going in here. And that gives us a snapshot of what's going on, how much work is being done. That's valuable to keeping our projects on time. So our biggest return on investment is bridge inspections. So as I mentioned, we've got a lot of bridges, so we can look at scouring down below, the foot detailing, cracking, and delamination. So delamination is kind of a fancy word of saying looking at thermal technology to see if there's delamination in the concrete. Traditional methods are just dragging a chain behind a truck and looking for sounds, recording sounds. The sound will change, but we can get high levels of, especially if it rains and starts heating up in the morning, we can get high levels and see where there's cracking on the bridge deck. So that's very helpful to us. Traditional methods are using a snooper. Snooper is just basically a big bucket truck. You can see it here. Sometimes we have to use it for extra critical bridge. We'll have to use a snooper, but when we don't have to use a snooper, we can augment it with a drone. You can see we have to shut down lanes here. That's a safety hazard for our motorist. Inevitably causes accidents, as I mentioned before. But if you can use a drone to do the same job, motorists will never know it's there. You can usually use one operator instead of 6 people, which would be required to operate the snooper trucks. So as I mentioned before, it's our biggest return on investment. We can save the state a lot of money. We could take the manpower out of there and operate safely and more efficient by using this technology. So this really illustrates how the aircrafts work and the level of efficiency we can use. So I believe this is the Ironton-Russell Bridge on the Ohio River. That was a crack there. They filled it with mortar. So they go back once a year and take a look at that. Traditionally, you'd have to have someone climb up the hatch, go away to the top of it, then rappel down to take a look at this. But we can take an aircraft out of a box, power it on, fly it, and determine this is the mortar still like holding. So we'll keep an eye on that with many other bridges like this across the state. So emergency shutdowns happens quite a bit. This one was a few years back, semi-carrying potassium hydroxide jackknife on the Brent Spence Bridge. If you ever go down to Florida or Tennessee or Texas or anywhere crossing that way, you know how bad it is crossing that bridge. So we got a twofer out of this one. We're able to do damage assessment of the bridge, and we're also able to move and direct traffic on the other existing bridges to have it flow better. Back in November, I think it was the Big Mac Bridge down in that caught on fire, so we assessed that one as well. So emergency shutdowns are something that's becoming more common for us. So natural disasters, I already mentioned that. So we're getting into the rainy season here in Ohio. So we have a lot of washouts. So we can measure the amount of damage. We can assess the damage and have a kind of a snapshot of how long it's going to take, is how much material we need to fill this back in. Tornadoes, another one that we do quite a bit. I kind of already mentioned that one. Flooding's another one. So obviously, if there's water on the roads, that's going to be a problem for us. So we'll look at ways we can put new drainage in, new drainage tiles, and put new culverts, and try to make the water flow away for future projects away from the roads. Another thing here that we look at here is see if I have a landslides. Rainy seasons cause this, and also a phenomenon called windjacking. So these trees grow out of the side of the mountain or the hill here, and the wind will blow them and it'll loosen the material. So we're actually looking at vegetation spraying. When those are seedlings, trees, we can spray them. There's a certain type of trees that grow out of that we always keep an eye on, so we can use that. Here's just more washout stuff. So I mentioned before, traffic's a big one. You can't see it in this picture, but this is traffic building up on a freeway, and you can really get that bird's eye view of traffic. For this particular one, the signal lights weren't timed correctly. So we can just look at all the traffic flows, give this data to our traffic engineers, and they can say, aha, we have a problem with this light, or maybe all three of them. So we can move traffic away from the freeway and have it move freer. Another one is school zones. This is in Springboro, Ohio. It's a 2-lane road, 741, if you're familiar with that road. We flew 6 aircraft at once, and we were able to speed up the time that folks flow during this rush hour time by 26%. Doesn't seem like a lot, but for the folks that are traveling through that every day, 26% was helpful to them, so they were appreciative of that. Another one we did during the pandemic was the mass vaccination sites. They had them in Cleveland. So we worked with Ohio National Guard and FEMA. The NFL draft was going on at the same time, so there was a lot more folks in the Cleveland area than normal. So we had parking as an issue, we had traffic as an issue, so we were monitoring all the activity along with that. Here's another one too, during the pandemic. This is in Cincinnati. Typically, folks would walk through this light show, but during the pandemic, people were just driving through it. So we had a lot of traffic building up on the freeway at night. That's even more hazardous when you've got accidents at night. So we were monitoring this pretty close, but this was our first night flights before the FAA changed the rules on night flights. So that was at the time was a big accomplishment for us. Here's our camera system here. Let's see if this was the Jeremiah Maurer Bridge. They imploded this a few years ago, and we monitored that activity. We're also doing a big scan with this bridge. We're going to use 150,000 photos to do what they call digital twins. We're getting crack technology. For whatever reason, this bridge is starting to crack faster than it should. So we can capture the bridge in real time, then compare models of the future to see what the level of cracking is and repair it as we go along. So that will speed up the process and ultimately make the bridge safer, more efficient as we move forward. So we had clunky boxes we'd feed into our pole camera systems. Now we can stream everything through iPhones, through an app. So that was a kind of a big technology leap for us. So we can respond to natural disasters and things of that nature in real time. And we have a QR code we can send the folks, and they can pull it up. As long as they have an internet connection, they can watch it anywhere in the state. So all the stuff I kind of showed you before is a lot of just pictures and videos, and pictures worth 1,000 words, which is true. But we're actually using science and mathematics to measure. This is a new on and off ramp going on. So we can get high level accuracies. We have a VRS core system. We can tie our aircraft in there. So we can get the X and Y, which is, forward, backwards, right, left. Then we tie them with Z, which is the altitude. So we get ground control points. We can stitch everything together and get high measurement as far as doing new construction. That's important to us because if your measurement's off, they could cost the state and the taxpayer hundreds of thousands of dollars in material, gravel, base layers, stuff like that. So here's another one too. This was actually the same project. So we were able to, this was the wall surface here, and we moved it back to here. So we were able to get high levels of rubble removal. That's important to us because our contractors will hire them to pull the material away from that, and they charge by the truckload. So we can actually get more accurate levels of rubble removal from our projects. That's important to us because the rock wall decompacts, so the vendors can charge the state more money. So we're kind of keeping them a little more honest with this. So that's been helpful to us. Here's another one too. So these are the stringer arms at intersections. Now they're putting all the big mast, the big heavy steel mast over that. And traditional methods for measuring everything, when you're putting a new intersection, you have to measure everything here. They would typically do that by just putting up a big pole and measuring everything like that. It's very time consuming. It also could be hazardous to our workers because they're close to the active traffic. But by just using a drone, we can measure everything in this picture, and our designers can go back to this day after day instead of going out there and measuring everything. It's like virtual reality at your fingertips, at your computer at your work, so they can do their job more efficiently. And here's some more sensors that we do. This one up here is at Grand Lake St. Mary's. So in the 1800s, late 1800s, everyone was drilling for oil. I mean, if you're farmers, you probably see these casings in your fields sometimes. So we're working with the Ohio Department of Natural Resources to identify these across the state. All these little blips here are wellheads. So they're big steel casings that go sometimes thousands of feet in the ground. We're using basically a big metal detector underneath the drone, so we're able to detect these wells in farmers' fields and over these lakes here. That was the first offshore drilling anywhere in the world. This is a LiDAR unit. So the Indiana brown bat's an endangered species. So we have an environmental group at ODOT that's been tracking these bats and try to get them off the endangered species list. So this is an old abandoned like railroad tunnel. And for whatever reasons, these bats were thriving here. So they wanted to look at the vegetation, look at the kind of cave structure to see, why are these bats thrive in this particular area. This is ground penetrating radar. We can see drainage tiles, septic tanks, grave sites. This is important to us because if we're expanding a road, sometimes we get close to drainage tiles and other things under the ground we can take a look at. This is actually a bat tracking program that we're working with the Ohio State University on, the same type of species of bat. That's multispectral right here. We can see drainage tiles as well here. This is a radiation detection. So we work with the Department of Health and the Air Force Research Laboratory on flying these aircraft. We've got 2 nuclear facilities in Ohio. If those ever go to Chernobyl, or to use their words, if there's a dirty bomb, we can send an aircraft in there before we send in humans. Sometimes we could hazardous cargo that goes through Ohio that's radioactive. We'll inspect that as well. This is an ectosounder device that can measure the depth of our riverways. So if we're pulling off debris that builds up on piers, we can kind of see if that needs to be dredged. This was a project for the Ohio EPA. Basically, this was a company that went out of business. That's all old homes that they put in the big deal debris pile. This picture doesn't do it justice. It was about 3 stories high. It cost the state $10 million to clean up. So we did a volume calculation in order to figure out that number. Let's see here. This is just more 3D model. We moved our office. This is probably good information to you. We're not at the, yeah, okay. So this is the Springfield Airport that we're at right now. And I'll show you another slide coming up more about this. There's a kind of exciting thing happening today and next week there. Here's a new technology too. We're getting some of these docking stations. So the Brent Spence Bridge, as I mentioned before, it's really congested over the Ohio River. So if you're ever going on vacation in the South, you've probably encountered that. But we're working with Kentucky Dot, and we're going to put a couple of these boxes down there so we can monitor the traffic and monitor the construction process. I think this is going to be the nation's largest construction project, I think ever, like $8 billion to build this new companion bridge. So we're going to be monitoring a lot of stuff going on down in the Cincinnati area with these boxes. They're self-contained. We can operate these from our desks. This is kind of the new wave of the future. We've got a remote operations center at our headquarters, so we can sit in front of the computer and actually fly these remotely from thousands of miles away. I'll show you a slide here about that as well. See if this goes here. This was we were working with our sister agency in California, Caltrans. So they have a couple of these boxes around the port of entry because they're redoing the port of entry by Tijuana. So they're just kind of keeping an eye on the construction project, and they got a couple of bridges. So this is us flying it from our place in Springfield, 2,000 miles away in California. So this is, as I mentioned, the wave of the future. This technology is going to get cheaper. Like if you're farmers and you want to use this for ag, you could probably put one of these outside and fly it from your kitchen table if you wanted to, and here in the near future. So this actually flew this yesterday. This is beyond visual line of sight operations that we got approval from the FAA to do. So traditionally, when you're flying an aircraft, you have to have an eye on it at all times and not fly beyond visual line of sight. But we got a waiver. We can use this for emergency response or big survey projects, so we can fly these beyond visual line of sight. So that's our Census aircraft Centero 5. So we're also, maybe this is getting off tangent a little bit, but we have got this boat now. So this is scouring underneath on our bridge deck. So you can picture the river flowing this way. Debris builds up on this side and it carves out this down below. So we can get a good idea of how structurally sound these bridge piers are and repair them or rebuild them if we need to. Traditional methods, our bridge inspectors will wade in the water and use a big metal rod to kind of measure the depth too. So this is a way we can do it higher precision, more accurately get the results we need to ascertain if this bridge needs to be repaired or not. So everything I showed you before was all of our operation stuff, how we're implementing this technology inside High Department Transportation operations. We're also working with companies in the Air Force Research Laboratory, which is based out of Wright-Patterson Air Force Base. It's our initiative called Fly Ohio. This is our Winnebago that has radar feeds in here. So we get radar feeds from John Glenn in Columbus, Dayton International, and there's a long-range security radar out by Molly Caron over there that we fuse all the radars together so we can get a picture of what's going on in the airspace. So this is important to us because we don't want to collide with manned air traffic. So there's two types of air traffic. It's called cooperative. Those are the folks using ADS-B and transponders. Everyone's at least heard of a transponder. So the FAA knows where people are in real time with a transponder or ADS-B device. But there are still some folks that are flying canvas airplanes with no electrical system. So we just see them with radar. So we can see both cooperative and uncooperative aircraft. And we've got operators on the ground flying various aircraft for experimental purposes. So we can kind of deconflict traffic or warn them if there's a manned air traffic coming in to the airport. This is our volume. It's 200 square miles. If you know where Springfield is, going towards Columbus, it's about 17 miles to the east. So this is kind of the information that we see on the radar system so we can deconflict. Let's see. This is just a live picture of it. I won't let this play all the way through. Just a minute or two, but we've got two former air traffic controllers that sit in there, and we work with the Air Force Research Laboratory when they're testing their new devices and sensors. They don't have to drive out to the Western test ranges or fly out there. They can go the right path to Springfield, test their devices, and they can go back and tweak it as needed. Let's see here. So this is happening today and next week. So here's an MQ-9 Reaper. These are the hunter killer aircraft that our service members, women and men service members use to hunt the bad guys. So in Springfield, they have a National Guard base there. So there's 2 ground control stations, and they'll fly these over in theater in the Middle East primarily, and they'll be launching recovery bases in the Middle East. Then they hand the aircraft over to the folks in Springfield, and they'll fly these. So that SkyVision radar systems allowed these aircraft to come in from California because we can see all the air traffic, and these guys can practice their launch and recovery right at Springfield with this radar system. So we can bring them, spiral them down safely from 20,000 feet and have them land on the aircraft, the runway here. So here's kind of some proposed things going on. The green areas are our operational area here. These are military operation areas. Our guard folks will practice maneuvers with helicopters and jets and do combat missions. So we're looking at putting a corridor from our Springfield airspace to the military operation area so we can have them practice with Reapers in the future. This is our smart corridor where our Drive Ohio folks are putting in ground transportation. The Transportation Research Center is located out there. That's North America's largest automotive proving ground. Honda is operating there, so they do a lot of testing there. It's a huge facility. The oval, if you can imagine the Indy 500, that's 2 miles. This track is 7 miles long, so it's absolutely enormous. There's a runway right in the middle of it too, so that gives you an idea how large it is. So in this red dot here is a proposed corridor. The first use case for this is organ delivery, primarily kidneys. Ohio does the most kidney transplants of any state, 52 a day on average, and those are about $260,000 per kidney. And there's a huge incentive to move kidneys faster because if they're out of the host for, let's say, 6 hours, that kidney might last 4 or 5 years. But if you could move a kidney faster within an hour or so, that kidney might last 20 years. So there's a huge incentive to move kidneys faster. So that'll probably be something that we'll keep an eye on here in the next 5 to 6 years to see how that develops. So here's some of the folks we're working with right now. Beta, Beta. They have simulators at our facility. They do some testing out here. Reliable Robotics has basically Cessna Caravans. They're putting all automation equipment in. This was a lift aircraft. This is an autonomous helicopter. And you have folks like UPS testing package delivery. And this guy right here is Joby. I don't know if you saw the announcement, but they're putting in their main manufacturing facility at Dayton, close to the Dayton International, over on the Dayton International property. So that's going to be like a $4 billion investment by Joby. And Wright-Patterson Air Force Base is probably going to be the largest customer. So they wanted to be kind of close to the Air Force Base. So we're working with all these companies, working on advanced air mobility. So I think that's about it. I think this is actually your group, John, like we did this years ago. Yeah, so I thought that was kind of cool. Too bad the Michigan State guy didn't counteract this. So there's the Block O2. So that's me sitting in a lift aircraft there. So that's my contact information. If you guys ever have any questions, give me a call. That's my email address. If you want that drone information, just hit me up and I will respond to you. Any questions? Am I going over time here? Oh, okay. Yes. Yeah, so he wanted to know if other states are doing this. Yeah, we're aligned with some of them. We're working on some agreements with Alaska. They have some airspace that here they want to use. We have some airspace that some of our folks want to use. So we are kind of working together. But it's kind of mainly being driven by just the private sector. You know, they're building these, you know, they're working on military contracts. So that's kind of the driving force, but they are kind of working. Like North Dakota's got a nice test range, but the problem is it's always cold there and it's hard to get to. But that's good for folks who are working on de-icing. So that's a perfect environment for them. But as far as practicality of flying, Nevada's pretty good too. Texas has got a test site. We have kind of an agreement with the Air Force Research Lab and Wright-Patt. It's kind of like the way it was described to me. Our nuclear sub base is out in Groton, Connecticut. And the docks were getting old where the submarines pull up to. So they were going to put everything down in Puerto Rico. If the military had to rebuild everything. But the state of Connecticut said, hey, no, we'll make an investment. We'll rebuild the docks as long as you stay there because there's a huge financial advantage. Kind of same thing with Wright-Patt. They're our state's largest employer. I think they employ 30,000 people. So they're our largest one. So our state wants to have a good working relationship. So we've kind of paid for a lot of this infrastructure to have them come test in Ohio. So that's brought the Jobies, the Betas, the Moogs, the Reliable Robotics out here because we had that radar system that state employees are operating. Did I answer your question? Yeah. Okay. Yeah. Questions? Yes, sir. Anyone can do it. People use it from around the country. Yeah, it's kind of tricky with our folks because our legal doesn't want us to, train people outside of it. Because if you crash a drone and it hurts a bunch of people, FAA is going to come in and say, well, where did you do your training? So there's a liability factor. So we're not doing training. We do what we call meet and greets with other other government agencies across the state. We show them our technology and show them like that. The gentleman behind you. Yeah, yeah. So he wanted to know about night flying and remote ID. Remote ID is an attempt by the FAA to put almost like a transponder, but it's more like an ADSB, which gives you GPS locations, a little more accurate. So it was kind of their way of trying to tracking drones. The problem with that is the range is very limited, and so it's on like a Wi-Fi signal. We've got some kind of special ones that are a little more advanced, like $260, but we've tracked them from 2 kilometers, which is a pretty good distance for these. But the problem is FAA is not really enforcing the remote ID. They don't have the manpower to kind of police that. Um, so that's kind of an issue. And I think that technology will probably change. And I hope it kind of changes more like an ADSB. The problem with ADSB is air traffic does not want to see those because they're focused on manned air traffic. So it's going to have to be like an ADSB technology, but on a different frequency. So it's not messing with the air traffic controllers. So, but yeah, that's an issue. Night flying. The FAA put in the exam recently within the last couple of years, some questions about night flying. So it's not illegal to fly at night anymore. So anyone can fly at night. Um, there's no property restrictions. It's a FAA's airspace, so they can fly over your house as long as they're not doing anything illegal, which would be like staring into your window, because we already have existing laws that deal with, voyeurism and privacy issues and peeping Tom issues, whatever the case may be. They can be prosecuted by doing stuff like that. But as far as the actual flying of the aircraft, FAA claims they own the airspace from your shoelaces or a blade of grass to the space. So yeah, we've had some discussions with the governor's office about that. We have we have we have security systems at our prisons because they have unwanted packages that come into their facility. So we've been tracking some of that stuff too. We can use some of that same technology. If this progresses, we could potentially do some demonstrations out that way. I mean, I guess it's a pretty large area from what I understand. So we kind of have to be more targeted within a few miles of an area that's maybe a hot spot. So we could look at that. But yeah, no one really knows what that is. So it could be the PETA folks. It could be folks looking to see where, if there's piles of dead chickens. I don't even know. Or some people have even proposed it could be a foreign agency trying to spread pandemic to hurt our food supply. But who knows? We don't know. We don't have any information on it whatsoever. Yeah, Dark County and Mercer County. Yeah, we're going to keep an eye on that. Yes, sir. Yeah, that hasn't been figured out. As it typically goes, the technology is outpacing the regulatory environment. So government tends to be reactive instead of proactive. So we're really seeing this with this technology. So there's a new, so it's Part 107 is the visual line of sight right now. They're coming out with Part 108. They said sometime this year, they being the FAA. So I'm not entirely sure that they're going to have that out and ready, but that could be something that's combined with the Part 108, because if we're flying them from computers, um, that might be an issue. But we could probably get a waiver. The area we want to fly is in Cincinnati's Class B airspace. That's good and both bad. The good reason about that is everyone that has to fly in there has to have what they call a Mode C transponder, or ADSB, to fly in that airspace. So everyone who's in that airspace, we can see and we know where they're at. So there won't be any deconflictions with helicopters, medevacs, stuff like that. So that's a good thing that it's in that airspace because we know where everyone's at. So it'll be kind of tricky to see how that goes. It might be a crawl, walk, run type of approach. But we're getting these docking stations. We're going to test it and build ours on this platform at Springfield Airport. Um, we can work with the Air Force Research Laboratory. Their flight division. They can do a flight release. We can fly under their authority and test this technology. And FAA likes to see you build ours, so we can put a lot of air hours on this. So we very comfortable with it. Probably make a few mistakes around the way, but we'll learn from that and be safer when we deploy this into the field.
They put the largest drone you're kind of testing over there right now, roughly speaking.
Yeah. Yeah, good question. On their operational side, we have a Perimeter 8. It's a hybrid electric. It's a gas, it's an octocopter. So it can fly for about 3 hours. So when we do the big magnetometry surveys, we can cover a lot of ground. It's just under 55 pounds with a payload. You're not supposed to fly anything over 55 pounds without a waiver. So we try to keep all of our stuff under 55 pounds. But our research side of the house, it's doing the sky vision radar stuff. They test, everything from up to 5,000 pounds with the air taxi. So imagine 5, 10 years from now, you live in Dublin, Ohio, which is outside of Columbus. There could be, a little vertiport in Dublin, probably at the OSU airport. You can hop in an air taxi, drop you off close to the stadium, and they just do that around the city. So, I mean, that's one use case I've heard too. So, um, we'll see that probably in the next 10 to 15 years. So, as far as we know. So,
So if you ever get to Springfield, UAS, I heard you mentioned is at the Springfield Airport. They got a new facility. They actually have some companies that have moved in and kind of doing testing. But like I said, at least the way I look at it is really facilitate the use of drones in the state. I'd say one thing I'd tell everyone here, the first time I ever seen a PICA, PYKA, for all you ag folks, that is a company that just got clearance through the FAA. That's a fixed wing, at least in the ag community, that's a fixed wing, about 80-gallon drone that just got some approval. They're going to be flying out in California first. But I was there a year ago, and they had a PICA at the facility doing for cargo reasons. So I'm just saying it's kind of nice to have someone close. Though you did see a lot of ag related stuff here, you can see obviously in the state there's a lot of things going on. So think about some of this and how that's helping us facilitate moving forward as well, I believe. So we appreciate what they're doing. But you get over there, you get to see some pretty neat drones that companies are testing or at present. It's kind of neat to see what some of the things coming here pretty soon.
Yeah, and at the end of 2024, Rickenbacker Airport, it's a military base too, south east of Columbus. They got a company that's coming in that's manufacturing low-cost attritable aircraft for the military purposes. So that was kind of a big win for the state. So we had some pretty big wins with Joby coming in. I forget, Argus or something like that. It's a new company coming in. So we're gonna be manufacturing a lot of these drones in Ohio, which is good news from an economic standpoint in our state. So.